Let's start the webinar. So, good afternoon, everyone. Myself, Naushad. I'm working as an application engineer for SolidWorks. So, here today's session is going to be on from designer to analyst. So, as a designer, you are going already designing the parts. So, you may get some questions in the mind whether this part will be in the real life, whether it will work or not, it will come in failure, and all these questions will be there. So, but before starting the session, I just want to tell you something. Why you want to do the simulation on the parts, what you have designed. So normally, whenever we want to have any parts or when we want to buy any parts as a consumer, in our mind, we check for the guarantee of the part first, or the quality we can say, and then the cost should be low, it should not be very costly in the market, and then again the guarantee itself. That is the guarantee, like at least 5 years or 10 years or at least for 2 years, like this. So all these three combined things gives you the better designs. So the designing of the part, as a designer, you should know how you are designing it, and all these three things has to be considered when you design a part itself. Okay, again, I want to ask you, as a designer when you're designing any part, these things or these factors you should keep it in mind. So let me go one by one. So how does your company check the performance on the designs? So performance on the design or means like whatever design you do, it may be a part or an assembly or a structural design or maybe a flow design, whatever it is. So what are the things you are considering? How will you check the performance of the design? This is one question. Second one. So what about the material price fluctuations? For example, as a designer, I'm designing this part and this part price in the market is this much cost, we can say. But unfortunately, it's too much. As the market is getting big and big and wider, the demand is more and more and more. So how do you manage this one? How you manage the price, market price? So we have in SolidWorks itself like optimization study and then design alternatives is also there. So we can find out through this study. Let's go to the third point. How do you differentiate your products in the market? That's one of the important things now in the market to survive. Otherwise, you will not be able to survive in the market. So we can use using the material alternative or virtual test optimization, where you will be able to know whether your product or the which you are designing it will sustain or not in the market. And then whether sometimes we design a part and we will come to a conclusion that whether it's over design or under design or whether this part will be fit in the market or whether it is like you're spending too much money on this part to manufacture it, all these things. So how to optimize your design in the best way? So we have the solution there. Optimize the study, optimize the design for this time, and then virtual performance testing also can be done on the part which you have designed. So the fifth one, what is the time life of your product? Like how much years this product will be without any damage or like this. So how to check the fatigue study? So we can do that also. And overheating phenomena, for example, how to avoid this overheating phenomena in the part of your operations, like bearings and all these parts. So we can do using the thermal analysis or thermal flow analysis also. And in some cases, like in the vibration industries or in the shaking, excessive shaking of the parts also can be tested here using the frequency analysis and dynamic analysis also. So these are some of the questions which we normally have to keep it in our mind when we start to design a part with respect to the verticals. I'm not telling that all people are doing in all type of industries. So it depends upon the vertical of the industry. Like some people may go for the static analysis, some people may go for the vibration analysis, some people may go for the frequency analysis. So we have to know what videos we are going to do and what will benefit us. So all these things, as a designer, you can design in SolidWorks itself in the same platform. You can analyze also or validate, we can say. So it's all fully integrated with the design in the one system or one platform, we can say. And then Apart from this, we can do for the calorimetric and structural analysis, and then for plastic industries, we have the plastic injection molding also, and then for the flow simulation, we have fluid dynamics analysis. All these things are also combined here. That is a multi-physics simulation, we can say. So here you can see just an idea to give you the different type of studies can be done in the SolidWorks itself. Once you design and then you go for the analysis immediately. You don't need to go for the other machines or other platforms to design it. Okay, just to give an overview about the products we have. So SolidWorks Premium, some of our customers or some of the valuable customers are having who are having SolidWorks Premium already they have two packages for analysis. One is the static analysis and then motion analysis where they can do it. Apart from that, we have in the simulation, we have simulation professional product and then simulation premium product. In simulation professional, you can see we can do different type of analysis like frequency, fatigue, pressure vessel, buckling, thermal, torque test, all these things comes under the simulation professional. And in simulation premium, you will go to the nonlinear and nonlinear dynamic and then linear dynamic analysis also. So this simulation package overview will give you an idea. So which part or which type of study you have to do, and with respect to that, we are able to assist you on that specific package. Okay, now let's go into the subject. So I will start with the static analysis in soil bracket. Okay, so you can see two brackets here. One is the single web design, another one is the double web design. So the design is similar. Only difference is that there is a single web, and here on the other side is the double web. So what I will do is I will try to apply 20 kg of force load here on the one side, and then the other side will be fixed on the wall. So let's see how this react. And my main aim of this analysis is that which design is better. So as a designer, I have options to design because I select the material, I can change the designs, and then all these things I can do. But I should know as a designer that which design is better for me. Better in the way like commercially, like low cost, and then it should not consume too much time to design, and then it should have a good quality or it should have good life. So all these things has to be considered, right? So let's go in action. So here you can see in the SolidWorks window where I will take the single web, and in the SolidWorks, as you all know that using the configuration console, we can have multiple designs or multiple designs can be done in a single configuration, and you can pass this file as a sorry. Yeah. So here you can see this part has a single web, and then I will go for the uh, configurations. Here you can see I have created two configurations for this part. One is the symmetric, that is for the single web, and another one is for the double web. So now what I will do is I will set my design for the double web first. But before setting that, I have to give the constraints, proper constraints, like in real life, how this part is going to be used. So here I am going to set a new CD static, and here you can see we have other choices of CD also, like frequency, buckling, thermal, all these things. So let me go for the static analysis first, and then I have to give the constraints or the boundary conditions we say. So as I told you, let me give the fixture first. So this end is going to be fixed on the wall. So what I will do is either I can go for the specific holes, or I have to select the whole face. Okay, just hold on. Just hold on. I think there is some issue. I think there is some audience issue because I can see some questions coming up. Somebody is not able to hear properly. Just hold. Hello everyone. There was some noise issue, so I just want to clear one more thing, one more time. That are you able to hear everyone? Can you able to hear me, or is it there is some echo or the voice is not clear? Please let me know. Yes, can you hear? Everybody can hear me now properly, because I saw some questions were coming, like still a little echo is there. Okay, I will try to manage that. Okay, I think now it's better. Yes, now it's good. I think somebody has told, yes, now it's good. So, okay, let me continue. So just let me know if you have any disturbance in the noise. Okay. Okay, so coming back here. So I have done the analysis. I have done the run the analysis here. I just want to check the results. So here you can see the results. So stress analysis is the results which we can see here. It's almost 11.36, and the area where the analysis is done on the bottom of the double web bracket. So here you can see, and then if you want to check for the displacement or strain also can be shown there. So now we are not focusing on that one, so we will go to the single web design. And another interesting thing is that for the another design, you don't have to define the boundary conditions again and again. Okay, so what you can do is you can just duplicate the boundary conditions which you have done before, and then you can copy and then just run the analysis. And now you can see the stress results is 8.412 megapascal for the single web. So what I will do is I will try to just modify my design again, like I will try to change the fixtures, because you remember that I have fixed on the whole face the fixture I have given. So I will try to define now the fixtures on the specific holes, like it is bolted on the wall. Okay, so here you can see I'm just trying to give a new fixture again on the holes. Yeah, again then I will run the analysis. So now you can see here the results are different, and the stress level is not on the complete web array itself, it's on the holes. Now you can see the stress is showing on the holes itself. So now if you ask me which design is better, so I will say, or I will can show you the comparison here. You can see the double web design, the stress results are 11.36 megapascal, and the single web is 8.41 megapascal. So the second, or the single one, is the better design, or the best design, I can say. Okay, how to generate the reports? So consider that you have done the analysis and you have seen the results also, but I want it as a report. Okay, so how to generate the reports? So you can generate the report in SolidWorks in an automatic way. You don't want to type in a Word document again and again. And to generate a report, you can generate different type of results, or you can include different type of results in the report itself. So here you can see this is an example where you can include the different type of results in the report with respect to the stress analysis, and then displacement, and then fatigue checkpoint, and then the factor of safety plots, and then one measure stress, shear stress with respect to X, Y, or Z. So all these things are there. So let me show you how to generate the report. So this is the sample of how the report will be. It will be generated in the Word document, and then in the Word document, the model information, the steady properties, the material properties, and the load and fixtures, all these things will be included in the report. Anyhow, let me show you. So here you can see the action. So here you can see I want to just add some more results in the reports. So I'm just trying to figure out which one I want to add here in the reports. So I'm just trying to take for the 1 inch of stress with respect to X, and then here you can see in the results it has been added here stress X in normal, and then I want to add some factor of safety also. So I'm just going for the factor of safety results. So here you go, factor of safety plot is being added here. And then what you have to do is you have to just want to create, or if you want to be more specific, you can just define more specifically in the results itself. So whatever you do with respect to the results, what here you can see is the results one, and then you can generate the report. Here on the top you can see the report option, or if you want to specify the image view where you want to bring in that image also can be brought here. So like include the image for the report, or you want to keep the part in a specific view and then generate the report, that also can be done. And now I'm just clicking on the report, and here you can see the report sections, which all the sections can be included, and then the description of the report can be given, and then the header information, the company name, and then the person who did all these things. So once you click OK, the report generation will start, and it will be shown in the Word document. So here you can see this is the report which has been generated with the images and then with the details or parameters. So in the conclusion, where you can write or you can type it, the suggestions what you want to give as a designer. Okay, now coming to the next one. So now, apart from the static analysis, let's go to the motion analysis. So here I'm just going to tell you about this HOLMATRO product. HOLMATRO product is a rescue device, we can say. Like for example, if anybody has been met with an accident on a car, they have to be rescued. So this jaws will expand in a way that it will tear the parts of the car, and then the person will be rescued. So this part has been completely designed and then invented in SolidWorks itself actually, and simulated completely in the SolidWorks itself. So let's see what we can do with this one. Okay, once I design this part or as the assembly, I want to know, will this work? So that's my first question. How this is going to work in the real scenario? Second one, will it fail? Whether will it tear the components or tear the parts properly to rescue the person? So like these questions will come in mind. And what is the fatigue or what is the life of this part? So what will be the life? So all these things I want to test on this part now or in this assembly itself. So let's go one by one. How will it work? That's my question. So now what I will do is in a virtual way, or I don't want to create any prototype. I don't want to do in a real scenario for testing this. All I can do is in the virtual system itself, that is in the HOLMATRO simulation itself. So I will try to apply 2 tons of force on either side of the jaws, okay, and then I will try to give the motor force and see whether with this jaws or this motor will withstand that force or not. That's my aim actually. So let's go and do it. So here you see this is the motion analysis window, and I'm going to apply a linear motor force. You can see the direction I'm applying, and then the motor distance is going to be 60 mm. Okay, and then I'm going to apply another force on one side. So the direction is going to be defined here, force of 20,000 Newton. On one side, I have to define the force on the other side, also the same force. So you can see I'm just selecting the other side for the same force on other direction, opposite direction of 20,000 Newton. Here we go. And then I'm just applying a contact with the jaws to the part. So here, this important thing we have to note here is that these jaws will come in contact with the part which you are going to tear. So here we have to specify the material of that. So here in this case, I'm going to apply or I'm going to specify the material as steel dry. So here you can see on the left side, steel dry, and then the elastic properties and damping rate, maximum damping also has to be considered. How much damping is going to happen there? That's also another important thing. So once it is done, I will just try to run the analysis. So you can see the analysis in action. So this is how the motor is going to react. And now I want to check the results for the force on the motor. So how much force is acting on the motor? That's my ultimate aim of the study. So I'm just taking the result here. So here you go. So the motor force is 81,81.41 Newton is the maximum force where this motor has been analyzed. So this is how we can define, or we can analyze the motor capacity or the actuators, and then it's like what if scenarios. If this is not going to work out, again you will try to change the force. But I have given here 20,000 Newton, so we will try to again change it, and then we will check again we will change it, and then like this. So it's like what if scenarios. So this is done. Let's go to the second point. Does it fail? So what will fail? I want to check this job. One part, it's a part. So if this motor is going to expand this jaws for that force, whether this part will survive or not, or will withstand or not. That's my aim of this next question. So let's do that one also now. So here in this case, what I will do is I will try to drag this analysis result to the part level, from the assembly level to the part level. So this can be done in an easier way, so that the time is reduced to design this specific part, and then the results what you get is in a faster way also. So here you can see I'm just opening this part in a part mode, and this part is open. And now let's use let's try to analyze this part, the normal static analysis. What I'm doing is here the linear analysis. And one more important thing is that the motion analysis is in the SOLIDWORKS premium package. Okay, so it's not in the professional or not in the standard package. That's another important thing. So now here you can see I'm just trying to give some fixtures on the holes for this part. So just try to applying some boundary conditions. So I'm just trying to hide other things and then run the analysis. Yeah, the analysis is done. Now you can see the stress analysis. So I just want to see the isoclipping also. So just highlight section view. You can see the section view in the result. So I can drag with respect to the plane, and you can see here the area where the stress is more. And in specifically, I can see the inside way, and the displacement result is also there. I can animate the displacement. You can see how it is going to work in the real scenarios. And then, of course, the factor of safety also. So factor of safety here is the value is shown here is 2.4. So this is done. Now you can see what I have done is just to summarize. What I did is I just try to have an idea or just want to know whether this part will fail or not, or withstand that force or not. That is what I have done now. So it's like this part is overbuilt, or this part is not in a sufficient way, or I have to change any material. So all these things has been considered, and then I did analysis for the second one. I mean for this part. So let's go to the third one. Will it last? So what is the guarantee, or how many cycles will whether this part will withstand or not? So that's the next question. So for this we have to go for the fatigue. So let's do the fatigue analysis. So here you can see the results already been done here. So just we are trying to start a new study. So fatigue is a new study. Here you can see I have selected the fatigue analysis, and then I'm trying to add the event here. So for how many frequency of fatigues I want to do it, and the amplitudes has been checked, and then I'm just running the analysis. And now I got the results also. So here in this case, it will give me the percentage of damage where it will be. So 5% is the place where the area it is shown in the red color, and here this is the total life is almost 40 million cycles is the result I'm getting for this part. So here you can see in the results on the right side, the graph. So it shows two results for the credit. One is the percentage of damage, and another one is the total life of the part. Okay. Yeah, of course. Just to summarize this one, ensure design will long last, or it will reduce the warranty costs. That's the important thing for any part we can do. So that's how we have done this analysis for this assembly. So all these three things will kinematics, and then using the factor of safety for whether this part will fail or not, and then for the fatigue, we got the results of 40 million cycles. This part will survive. Okay, coming to the next topic is SolidWorks simulation. For example, you have a clipper or something where you in the real scenario you will have pins, bolts, and then welds, welded parts of that, or joints of that, all these things. But in case when you're coming for the analysis, you don't want to, or you don't have to create any pins like in the real way. But in virtual way, we can give the pins. In the virtual way, we can give the bolts and the welds, the length of the welds, and then the size of the weld. All these things can be done here in SolidWorks while doing analysis itself in a virtual way. You don't need to sit and create each pin, each bolt again and again for the analysis. Okay. So let me show you how to do it. So here in this case, I have taken a clipper. So in this clipper, you can see there are three pins will be coming on the assembly, and then there's a spring, of course, there's a spring also, and I will try to apply 17.5 kgs of force from the top and bottom, and I want to check how it is going to work without the design of pins and then springs, all these things. Okay, let's go to the SolidWorks. So here you see this is the assembly, and here in this assembly you can see there are some pins already there, and then the spring is already there, and they have done the animation to show us the motion how this paper will work, right? So now what I will do is I will just open the but I will just try to activate the configuration which does not have the pins and springs. And on the left side of the screen, you can see the connections which has already been done here. And how it has been done is that in the SolidWorks, we have the virtual pins here. So here you can see in the top, in the simulation connectors, we have pin connectors, spring connectors, bolt, and then bearing connectors. All these things are used to connect in a virtual way where it should be. And of course, it has to be with respect to the material. So we should know what type of pin material it is. So we have to apply the proper material for the pin also on the connectors. And then once you're done with that, you can go for the analysis and then run the analysis and see the results. Here you can see the results as usual with respect to that. In the stress analysis, the important thing is that the red colors what's showing in the table here is with respect to the pins which is on a failure mode. Like you have to change the pins, or you have to change the material of the pin like this. So these pins are not going to withstand in that area. And now you can see the screen here. The pins are the four pins are okay. The one which is okay, you can see on the left top right, left top, and the needs attention. There are two pins which needs attention. So you have to make sure that these pins are not with respect to the factor of safety. So the desired factor of safety is not meeting the pins which is there. So that is the one part. Another part is for the welded joints. So we have in this bicycle frame some welded joints connectors, we can say. So like the pins, they have created the welded joints here, and here you can see the results. These are the welded joints or connectors where you can select each welded joints, and you can see the results here, whether which one is good and which one is bad. Like in the red color, you can see it's not good. And I just want to show you the weld check now also, where you can see 4 or 5 weld check connectors needs attention with respect to the weld size. So the calculated weld size and estimated weld size is not matching at all. And the other weld sizes are okay. So here you can see just an example. And fatigue check. Fatigue check here in this case, you can see the red area. This is the area where we have to make sure, or we have to make concentrate on. It needs an attention that we have to change the design, or maybe we have to give some fillets to make it more stronger on that specific area. So this is how you can do the analysis with respect to the weld more, and then pins, and then weld connectors, right? Okay, let's go to the next part. So this is just to summarize the results what we have seen. Here you can see the types of pin and bolt bearing forces, the pin and bolt check, and then edge weld results, what we have shown you, and then weld check plots to check whether the weld is properly there or not, all these things. Now, coming to the buckling study, everybody knows what is buckling. So in real life, normally buckling study is done here with respect to the structural. So as you see, the bicycle frame sometimes, and then maybe sometimes it can be done on a part, or maybe sometimes it happens in the assembly also. So let's show you a case study here. So this is just an example. Here you can see a barrel where it's inside the fluid is there, or water is there. How, let's see how there is a mixed tank, because normally the type of loads are going to be a compressive loads, and apart from the compressive loads, there are going to be force, pressures, and torques. Also has to be considered all these things during the analysis. So let's do it in action here. So here you can see the example. So I'm choosing the buckling study as a new study here. I'm going to start a buckling study, and then I'm going to apply the material for the bodies. So it is considered as a bodies here. So I'm going to apply a plain carbon steel material, and then I'm trying to apply a fixture on the bottom of the legs where it is going to be fixed on the ground. Yes, and then I'm going for the gravity, because sometimes we need to apply the gravity also for the entire structure to see how it's going to react. I'm just creating a mesh and then run the results now. So normally, once you get the result, you will get the buckling factor of safety, and buckling load factor also has to be considered, and unbuckling mode, where you can see here, this is how the buckling is going to be for this type of structure. And with respect to that, it will give you an inside design changes you need. Okay, coming to the interesting topic is design study. How do I reduce my weight of my component? Normally, as a design engineer, I will design a part which has been told to me, but I want to design in an optimized way. How to do that? Or maybe you have designed a part already. I want to optimize that part. So SolidWorks helps you to optimize the part with respect to different iterations. So SolidWorks, what it does is it will take some iterations, or it will do some iterations, and it will give you the optimal design with respect to the weight, with respect to the material, with respect to the cost, and many factors has been considered here. So let's do it. So here you can see this is the part which has been designed here. I want to create a new study, and then I will create a study as a design study here. So here you go. You can see I'm just applying some materials. I mean just applying some fixtures here, because this I want to first analyze as a static analysis, the normal static analysis, and to see whether what is the weight of this part. Okay, so I'm just trying to do that one. So here you can see I'm just trying to run the analysis, and then I got the results of stress, displacement, and strain. And now I want to check the weight of this one. So weight is almost 49 grams, 49.8 grams. So now I want to reduce the weight of this part. So in optimized way. So now what I will do is I will try to create a new study called design study. Yes, I'm creating. And here we have to consider the three factors is the variables with respect to the dimensions, where we should know where we can reduce the dimensions or where we can reduce the material. And then we have to consider the constraints factor also, and the goals. So here you see I have just applied the variables here. I'm just trying to apply the variables with respect to the cut here on for this part or this scenario. And then now I'm giving the factor of safety for this part. That is the constraint for me. And static 2 is nothing but the analysis results which I have done before. So now it is just trying to optimize it, and it is trying to take 27 scenarios. Now you can see how the design changes. You can see, and here the green one is nothing but that is the optimal result which the SOLIDWORKS is giving me. So now you can see the weight of the part or the mass of the part is 33.3 grams. So it's almost 20% it has reduced the weight, and it has done 27 of 27 iterations. So this results can be taken for me for this part with the optimized one. So here you can see, just to summarize it, the mass of the component has been reduced from 50 to 33.3, that is 34 grams, like this. So this is what is just an overview of SOLIDWORKS simulation. And apart from this, again, I am coming back to my previous slide just to show you the packages which I have showed you before, just to make sure that you will not. Just I will go back to that slide. Yeah, this one. So as I told you, SolidWorks Premium is also known as SolidWorks Simulation Standard. We say Simulation Standard also for SolidWorks Premium package, where it has these two packages of analysis, and then Simulation Professional has the other types of analysis, and then Simulation Premium has a non-linear and non-linear dynamic static, and then linear dynamic also. So this is the end of the session. Just I want to end the session with a small video. So just to show you the importance of simulation. You can see here. Yes, now coming to the end part of the session. So just let me know if you have any queries, or you need to ask anything, and you can please type the questions here. Okay. Yes. I got one question. Yes, we can. You can see the recorded part of this webinar. We can send you the link the through the email so that you can just review it, or you can show to your colleagues in the company, or you can show it to your management to get an idea of what the SOLIDWORKS, or you can contact us directly so that we can have a meeting with you also and to study your requirements. So apart from this, any other questions you need to ask, then please ask me. Okay, thank you very much everyone for joining me. Yeah, I got one question. These reports are accepted by government authorities for approval. Yeah, I got one question related to the reports. So these reports are accepted by government authorities for approval. Yeah, we can yes, this reports we can go for the SOLIDWORKS directly, and then we can have an agreement with the SOLIDWORKS itself, and then we can get approval from the SOLIDWORKS itself, the team who is for the simulation specifically, and then they will guide us what is the next steps to get the ways to get an approval, and then what is the procedure like this. So that's how we will we work on this types of approval with respect to specifically to the government authorities. So I hope I have answered your question. So anyone has any other question, please let me know. Okay, thank you very much for joining us. Thanks for your time. Have a good day. Take care. Bye bye.